Hello, my name is Lara. Welcome to episode 1 of Simple Science. Today I'm going to be explaining how soap works. Okay, so how does soap work? Well, to understand how soap works, you have to understand the different types of chemical bonds. We're going to start with purely covalent. For our example, we'll be using oxygen. Now, oxygen is not just one oxygen atom floating around. It usually comes in pairs. And how those pairs hook up is they share their valence electrons. Now, the valence electrons are the electrons on the outside orbit around the atom. Oxygen has 6 valence electrons, but it wants 8. Every atom on the periodic table wants 8 valence electrons, except hydrogen. It's the funny one. So, what they're going to do is they're going to share. This atom is going to share this electron with this atom. This atom is going to share this electron with this atom. So they've each gained 1. Now they have 7. And they have formed a single bond. So they share again. Now they each have 8. It's a double bond. Now there are no electrical charges on this molecule. A molecule is more than one atom put together. And the reason there are no electrical charges is the protons in the center of each atom are evenly counteracted by the electrons around. There's the same number of protons and electrons around each atom at any given point in time. So the charges cancel each other out, and there's no net electrical charge. Now the next type of bond is polar covalent. It's a little bit different from purely covalent, and we're going to use water as our example. So, water is H2O, 2 hydrogens, 1 oxygen. Now oxygen, same as before, 6 valence electrons every time. Hydrogen has 1 valence electron. Hydrogen actually has 1 electron total, but it wants 2. It's the only one that wants 2. So it's going to share, same as in the last time. Just like this and like that. Hydrogen now has 2, 1, 2. This hydrogen, 1, 2. This oxygen has its 6, 7, 8. So they're all happy. Now it looks just the same, but this oxygen has a lot stronger pull on the electrons than these hydrogens do. So the electrons stay around the oxygen longer. The electrons are negatively charged, so the oxygen ends up with a negative charge part of the time, not all the time. The hydrogen, at the same point that oxygen has a negative charge, they end up with a positive charge from an overload of protons. So they end up with a positive charge. And that's the difference between purely covalent and polar covalent. Funny thing is, polar covalent things like water can dissolve other polar covalent things, and they can dissolve ionic things. Ionic is what we'll do next. But polar covalent things cannot mix with purely covalent things because purely covalent things don't have any electrical charges floating around. It's like they speak 2 different languages. Okay, now for our ionic bonds. We're going to make Li here. So we've got our sodium, our hydrogen, and our oxygen. The oxygen, with its 6 electrons, wants 8. And it gets 1 from the hydrogen. And the hydrogen gets 1 from the oxygen. Hydrogen has 2, oxygen has 7. Hydrogen's happy, oxygen wants 1 more. So it just steals 1 from the sodium. Now, with that electron comes a negative charge because the electrons are negatively charged. So now, this whole part is negatively charged. This is called hydroxide. It's a polyatomic ion. An ion is usually an atom, but sometimes a molecule, with either a negative or positive charge total. Now, sodium is missing an electron, so it has a positive charge because it's got 1 more proton than electron. And the positive and negative charges attract each other. And so these 2 groups stay together, and that is what keeps the molecule together. This is an ionic bond. Now, here's what soap looks like. This one over here. Bunch of carbons all lined up. Each have 4 electrons from some other atom, hydrogens and carbons, and that is all covalent from like here over. Everything's covalent. But this part has some ionic bonds in it too. This is covalent here, the oxygen and the carbon. This is covalent, the carbon and the oxygen. But this oxygen only got 1 extra electron from the carbon, so it needed 1 more. So it took it from the sodium, just like in the lye. So now it has its negative charge, and the sodium has its positive charge. The sodium and the oxygen stay together because of their opposite charges. Now, the covalent end, this end is purely covalent. It can dissolve other purely covalent substances. It can't mix with polar covalent substances like water. So the water is pretty well stuck to this end of the atom molecule. And since they have the charges, they line themselves up and stick together pretty good. So the water can pool pretty well on this end of the soap molecule. This end of the soap molecule will hook up with the oil or dirt or whatever it is that is purely covalent. And it'll just pull it right along with the water. And that's how soap is able to make oil and water mix and to get grease off of your hands when just water won't. Thanks for watching.